Hello everyone, I am Geeta, Assistant Professor, Department of Mathematics, SNS College of Engineering. In this session, we are going to discuss about Latin square design. In last session, we have discussed about randomized block design, that is two-way classification. This one is three-way classification. Here, it controls the variation among rows, columns as well as treatment. So, which is coming under three-way classification. Here the treatment are assigned blockwise randomly. Consider this problem. A variable trial was conducted on B with 4 varieties in a Latin square design. The plan of experiment and per plot yield are given in the data. Here we are going to analyze and interpret the result. Here they have given the data, 4 rows and 4 columns, and the treatments are given here. A, B, C, D, 4 variety of treatments are given here. Corresponding output yield values are given in this data, that is 25, 23, 20, 20, 19, 19, 21, 18, 18, 19, 14, 17, 20, 17, 20, 21, 15. Here we have to first frame there is no significant difference between row, column and treatment. That is our null hypothesis here, which will be denoted by H0. After that we frame H1. That is, there is a significant difference between rows, column and treatment. Here they have given 2-digit data. First of all, we convert this into single digit because of simplifying the calculation. So here we take 20 as the origin and subtract each and the element by 20. So like 25 minus 20 we get 5, and then 19 minus 20 we get minus 1. Likewise, each and every element is subtracted by 20 and it will be tabulated here. Okay. After that we have to calculate the column wise total, adding this x1 value which is 0 here, and the summation of x2 minus 4, summation of x3 minus 1, and the summation of x4 is minus 7. Next we calculate the row wise total. So summation of y1 is 8 and summation of y2 is minus 3, summation of y3 is minus 10, and the summation of y4 is minus 7 here. So total value is equal to minus 12 here. After that we need to calculate x1 square, x2 square, x3 square, x4 square. Squaring 5 we get 25, minus 1 the whole square we get 1, minus 1 the whole square we get 1, and minus 3 the whole square is 9. So adding this x1 value, x1 square value we get 36. Likewise we calculate x2 square, x3 square and x4 square. After that adding will be, we get summation of x2 square is 46, summation of x3 square is 11, and the summation of x4 square is 29 here. Next, first we find the n. N is nothing but number of data. They have given 16 data here. After that we find t. T is nothing but total of observation. Here we get minus 12. So t equal to minus 1. Then correction factor t square by n value which is equal to 9 here. Next we calculate total sum of square calculated by the formula summation of x1 square, x2 square plus x3 square, summation of x3 square plus summation of x4 square minus t square by n. Substituting the summation of x1 square and x2, x3, x4 square values here, and it will be subtracted by 9, that is equal to 113 here. Next we are supposed to find the sum of square between column, that is summation of x1 the whole square by n1, summation of x2 the whole square by n1, etc. minus t square by n. Here n1 is nothing but number of elements in each column. Next we are supposed to find SSR value, that is sum of square between row, which is calculated by the formula summation of y1 the whole square by n2 plus summation of y2 the whole square by n2, etc. minus t square by n. Here n2 is nothing but number of elements in each row. So by substituting the values and simplifying, we get which value is equal to 46.5. After finding this value, next we move into the summation of sum of square between the treatment, that is take it as SSK. So in treatment wise we segregate, we separate the values of A, B, C, D in the table here. So collecting A values and B values, C values and D values, and which will be tabulated here, and its total is minus 12. That means summation of A equal to minus 12, summation of B equal to 1, and summation of C equal to 6, and summation of D equal to minus 1. Next we find SSK values. Here we segregate the treatment A, B, C, D values and summing up. Summation of A is equal to minus 12, summation of B equal to 1, and summation of C equal to 6, and summing of D is equal to minus 7. So SSK is equal to minus 12 the whole square by 4, because summation of A equal to minus 12. Taking square, and it will be divided by 4, because here we are having 1, 2, 3, 4 elements. So likewise we find 1 square by 4 plus 6 square by 4 plus minus 7 the whole square by 4, and it is subtracted by the correction factor, which value is equal to 48.5. Next we need to find the SSE value, that means error value, that is equal to TSS minus SSC minus SSR minus SSK, which is 10.5. Next we prepare ANOVA table. In source of variation, we are using between column, between row, between treatment and the error values. Its sum of square is SSC and the SSR, SSK, SSE, and values are tabulated here. Next, corresponding degrees of freedom. In Latin square, our main point is number of rows is equal to number of column is equal to number of treatments. So here we are having 4 column, 4 row and 4 treatments. So its degrees of freedom is k minus 1, that means column minus 1 we get 3, row minus 1 which is equal to 3, treatment minus 1 equal to 3, and SSE equal to k minus 1 into k minus 2, which value is equal to 6 here. After that we find the mean square value, that means SSC divided by its corresponding degrees of freedom we get MSC value, SSR divided by corresponding degrees of freedom we get MSR value, SSK by corresponding degrees of freedom we get MSK value, SSE divided by corresponding degrees of freedom we get MSE value. After calculating this value we go for variance ratio, column wise F ratio, which is equal to MSC divided by MSC. Here we must check whether numerator is greater than the denominator. So MSC is 2.5 and MSE 1.75. So MSC greatest value, so MSC divided by MSC, which value is equal to 1.43. Likewise we calculated F ratio by row wise, which is equal to 8.86, and treatment wise, which value is equal to 9.24. Next we find the table value at 5% level. So corresponding degrees of freedom 3, 6, which values are 4.76. Now coming to the conclusion, here calculated F value by column wise is less than table value. So we accept H0 in column wise. Coming to the row and treatment wise is calculated F value is greater than the table F value. So we reject row and treatment wise here. Thank you.